When I look at these problems, the first thing I do is try and see if one problem will help me answer another. Which of the following best describes deductive reasoning? Well, that would be using logic to draw conclusions based on accepted statements. In the diagram below, angle 1 is congruent to angle 4. Angle 1 is congruent to angle 4. Which of the following conclusions does not need to be true? Angles 3 and 4 are supplements? No. We'll keep going. A proof problem. Use the proof to answer the question below. Blah, 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 blah. Reflexive property, let's see. Sides, sides, and more sides. Side, side, side. There's that assumption problem. We did this one in class. Assuming this, that has to be false, giving me D. Oh, another proof problem. Okay. Blah, blah, blah. Angle 2 is congruent to angle 3, given. Okay, they say that. Angle 1 is congruent to angle 2. And angle 3 is congruent to angle 4. Oh, that's vertical angles. So I look at this statement separately and then this statement separately to connect. Backwards this way, forward that way. Two lines in a plane always intersect in exactly one point, which is a counterexample. Two lines in a plane. Coplanar lines, well, they could intersect, so that's not going to help me. Perpendicular lines, they also intersect, so that still just demonstrates this. So coplanar lines, no. Perpendicular lines, no. Intersecting lines, no. Which ones do not intersect? Oh, parallel lines. TRAP is an isosceles trapezoid with diagonals RP and TA. Which of the following must be true? Let's see, diagonal RP, segment TA. What has to be true for an isosceles trapezoid? Right there. Segment RP is congruent to segment TA. These problems are all pretty basic, so let's keep going and see what happens. Parallelograms, blah blah blah. Number 18. Which of the following best describes the triangle shown below? Let's see. That's 8, that's 8, that's 30 degrees, that's 60 degrees. Oh, that means that's 30 degrees and that's 60 degrees. Oh, these are congruent. Okay. So I'm going to call these both similar and congruent. Technically, this side is 1 times that side, this side is 1 times that side, this side is 1 times that side. So they're similar with a scale factor of 1, which is kind of silly, but it'll work. Which method below could not be used to prove two triangles are congruent? All 3 sets of corresponding sides. Side, side, side. That works. Prove all 3 sets of corresponding angles are congruent. Angle, angle, angle. That does not establish same size. Great. In 21, we say, which additional information would be enough to prove that triangle ABC and triangle DEF are congruent? Segment AC and DF. Angle A, angle D. Okay, so I could do side angle side, I think. That would give me segment AB and segment DE. Do we have that? We do. That has to be the right answer. In the figure below, what is the smallest possible value for n? Well, we do n plus n has to be greater than 15, and it says n is a whole number, so no decimals or anything allowed. So 2n has to be more than 15. Okay, so divide both sides by 2, and I get n has to be more than 7.5. 8. What values of A and B make quadrilateral MNOP a parallelogram? MNOP is a parallelogram if 4A plus B equals 21, and if 3A minus 2B equals 13. What's the best possible way to quickly get through this? How about we do a... Alright, we'll double this first equation and we'll get 8A plus 2B equals 42. Then we'll add these. 11A equals, what is that? 55. Okay, A is 5. B. Notice how I didn't have to do anything about B's value because here Once I find A, there's only one candidate that makes it correct. For 25, just to make sure quickly you guys remember how to do the lengths of a triangle, 2 plus 2 is 4. No, too small. 3 plus 3 is 6. That's that one. We're done. Alright, for the quadrilateral shown below, what is the sum of angles A and C? Well, let's go like this. What's 95 and 32? 5, 7, 9, 10, 11, 12, 127. Okay, so this is 360 degrees because of the formula n minus 2 times 180 degrees. This needs to be in your memory. We do that, we find out that's 360 degrees, so 360 degrees, take away 127 degrees. Well, it ends in a 3, and this is way too small. If ABCD is a parallelogram, what is the length of segment BD? Diagonals bisect each other. Alright. 32. Given angle line P is parallel to line Q, line M is parallel to line N. So angle 1 is congruent to this angle here, which is congruent to that angle there, which is the supplement of angle 2. So if angle 1 has a measure of 75 degrees, then I know that these two guys need to add up to 180 by this whole corresponding supplements. 105 degrees. A right circular cone has radius 5 inches, height 8 inches. What is the lateral area? And look, they give me a formula. This is one we did in class a little while ago. I need to find L using the right triangle right here. So what I do is I go, hey, 5 squared plus 8 squared is, what is that, 25 plus 64. Hey, that's 89. But once I do that, this answers itself for me. If a cylindrical barrel measures 22 inches in diameter, diameter. So that means the radius is 11. How many inches will it roll in 8 revolutions along a smooth surface? Well, let's see. 2 pi r is the only formula I remember. Some of you will remember pi d, which means you can just go straight to the 22. So 22 pi is the circumference. Oh, okay. 8 times 22 pi. Well, gosh, what's 2 times 8 is 16? It ends in a 6. Done. So see, last digit trick, 16. Ends in a 6. Oh, 6. That's the only one that ends in a 6. Great. Onward we go. The 4 sides of this figure will be folded up to make an open box. We have to remember, draw all over the materials. Alright? You get your own copy of the math text for a reason here. You're going to write all over it. You're going to scribble things in. You're going to cancel things out. You just do all that kind of stuff. This is 5 by 5, so the area of the base is 25 square units. This is going to fold up to this to be the height, so the height is 2. Oh, okay, so the volume is 25 times 2, which is 50 cubic centimeters. The minute hand of a clock is 5 inches long. What is the area of the circle that it sweeps out in an hour? Well, you have to think about the minute hand going all the way around the clock in 1 hour, right? So that's a full circle. So that's 5 times 5 times pi. A classroom globe has a diameter of 18 inches. Which is the following surface area? Diameter of 18 inches, so its radius is 9 inches. Is that right? 9 inches, okay. So 4 pi r squared. Well, pi r squared is 9 times 9 is 81. We're going to do this one without actually approximating. Pi is 3.14, so 81 times 3-ish. 80 times 3 would be 240, so this is like maybe 250 or so. Oh, but look at these numbers. These are actually pretty close numbers. And then I have to use times 4. So 250-ish times 4. So right, we would have 4 pi 9 inches all squared. And if I do this real kind of slow, then I get 4 pi times 81 square inches. And you see 81 times 4, that's, what is that? Oh, that's 300 and... That's 300 and, what is that, 320-ish, 324-ish pi. Notice that I'm writing the word ish. 324-ish times pi. Pi is 3-ish. 300 and some odd times 3 some odd is like 900-ish, so it's got to be more than 900, so D is the only possible answer. For number 40, Vic is constructing a spherical model, blah, blah, blah. 75%. 75% is equal to 3/4. You got to remember that. So then I can say, oh, 3/4 times 4 pi 24 squared. Well, 3/4, those cancel, leaving me 3 pi times 24 squared. 24 squared I have memorized is 576. So this is 5, 10, 15. So this is 1500-ish times 3-ish. 15, 32, 45. So this is like right around 4,500 to 5,000. I think that's the right answer. All right. Up here, we know 20 by 10. 20 by 10 is 200. So the area total of the rectangle, blah, 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 ends in a 0. 4 by 4, this triangle has an area of 8. So 16, 24, 32. So minus 32. Hey, look at these answer candidates. 0, something ending in 0, minus something ending in 2, must end in 8. If RSTW is a rhombus, then I have to figure out the area of just triangle WXT. Oh, okay, so I just want this thing. Well, that's a 30, 60, 90 triangle, no doubt. And if this is 12, then I could do the one... I could do the whole one root 3, 2 thing, but that's not exactly what I want to do. Really, if I remember right, the hypotenuse is a long side, the short side is half that, and then this is blah root 3. Okay, so to find the area, I say the area is 1/2 times the two perpendicular lengths times 6 root 3. That's 36. Or I could do this, cancel that as a 3. 3 times 6 is 18 root 3. Okay, we're done. Yeah, we got that side done too. Keep going. What is the area of this trapezoid? Well, if this is 12, then that's 6, 7, 8, 9, 10, 11, 12. Hey, 3 blank 5. 3 squared plus height squared equals 5 squared. The height is 4. 12 plus 6 is 18. Divide by 2, and I think that the mid-segment is 9. The height is 4. That's 36. How about this triangle below down here? Well, if you are as awesome as I am, you can memorize the equilateral triangle formula. That's root 3 over 4 times the side length all squared. I'm sorry, not all squared, just the side length squared. When I do that, then I can say, I'm certainly going to divide by 4. Well, let's see, 10 squared is 100. So this is root 3 over 4 times 100. 100 divided by 4 is 25. 25 root 3. I worked this problem all the way out, even though probably I didn't have to. Certainly I could first cancel the things without root 3's in them, because look, equilateral. What is the area of this trapezoid? X to X, that's 8. X to X, that's 12. That makes a mid-segment of, well, 12 plus 8 is 20, so 10. The height is 5. 44, the area of the figure in shaded region. 5 by 3. Oh, these are congruent, right? So that's also 3. It says congruent parallelograms. 5 times 3, the area is 15, 30, 45, 60. So this is really 12 by 12, 144 minus 60, I said. Well, 14 take away 6 is 8, so there you go. Leah made 2 candles in the shape of right rectangular prisms. Okay. Great. This one here is 15 by 8 by 8. And the new one is 5 centimeters taller. Okay. 5 by 8 by 8. So this is the only part that I care. 8 times 8 is 64 times 5. 64 times 5? Kind of hard. So it's 64 times 10 all over 2. Isn't that still 5 right there? That's 640. Divide by 2, 320. Very cool. This might be a cool trick for you. Anytime it's hard to do some multiplication in your head, you can just cheapskate it. Area in square centimeters of this. If RT is 16 and SV is 12. Oh, hey. 16 times 12 times 1/2, right? That's 1/2 times the product of the diagonals. That's 8. 8 times 12. 12 times 8 is 96. The perimeters of two squares are in a ratio of 4 to 9. And I have to find the areas. Well, perimeter is one-dimensional. Area is two-dimensional, so I better square this. 36. No, not 36. What is 4 squared? 16. 9 squared is 81. There you go. Two angles of a triangle have 55 and 65 degrees. Okay, draw it. Duh. Seriously? That's the ticket. Draw it. Draw it, draw it, draw it. 55, 65. Okay, 65 and 55, that makes 120, so this has to be 60. So let's figure out the exterior angles. For this exterior angle, I know that's 120 because those are really easy supplements. Now this is 5 less, which makes this 5 more. This is 5 more, which makes this 5 less. 115 I have, 120 I have, 125 I have, 130 I don't have. The sum of the interior angles of a polygon is the same as the sum of its exterior angles. Okay, so you could go through all this crazy nonsense, n minus 2 times 180 degrees, which is the sum of interior angles, and then equals the sum of exterior angles. Do you remember what the sum of the exterior angles is? It's always 360 degrees for every polygon. So A, oh, whoa, 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 whoa. Well, if 180, this number is 2, if this number is 2 times 180 degrees, then I know it's true, right? So when that's 2, 4 take away 2, 4 quadrilateral. Oh, we just did that page. Excellent. All right. On this side, number 52, what is the measure of angle x? Exterior angle theorem. 60 plus 25 tells me that answer. If the measure of an exterior angle of a regular polygon is 120 degrees, exterior angle 120, 120, 120. That's, hey, 1, 2, 3 angles. That must make it a triangle. In the figure below, this stuff is parallel. Line segment AB and line segment CD are parallel. Ah, what's the value of x? These are consecutive interior angles, which means they're supplements. So x plus 40 plus x minus 40 equals 180. 40 and 40 cancel. 2x equals 180. X must be 90. Good. Double check that it says what's the value of x, because it could ask you what's the measure of angle D or what's the measure of angle A, in which case I'd have to make sure I added 90 back to those numbers. The measures of the interior angles of a pentagon, 5 minus 2 times 180 degrees is 3 times 180 degrees. 3 times 18 is 54, so this is 540 degrees. All right, so I do 2x plus 6x, that's 8x, 9, 10, 11, 12x, 13, 14, 15, 16, 17, 18, 19, 20. I have 20x, and then I have constants. Take away 6, take away 16 is minus 22, plus 2 is minus 20. Equals 540. Okay, divide through by 20 right now because you're lazy. X minus 1 equals 540. Well, let's see. 100 would be 5. 500 would be 25. 26. 27. Then I add 1 to both sides. X equals 28. Let me give you a little test foo strategy. Which of these numbers is really unusual compared to the rest? 28, right? When this oddball number is too big or too small, odds are this is x, not the answer you're looking for, because see, they don't want x, they want what is the measure in degrees of the largest angle. So they are trying to fool you. Now that I know x, and in fact I probably could have banked on this being x without doing this work, but save that just in case you totally run out of time. I look at this, this says x is 28. Now that I know this says x is 28, what I will do is I will say, a number ending in 8, which one of these has to be biggest? 2x, 6x, 4x minus 6, 2x minus 16, or 6x plus 2? For a number of this size, 6x plus 2 will be the biggest. 6x is the second biggest, just to make sure you know. 6 times 8 is a number ending in, well, let's see, 8 times 6 is 48. So it ends in 8. Number ends in 8. But then I add 2 to it, and it ends in 0. No, there you are. Down here, what's the measure of angle 1? Ooh, okay, so that's 36 degrees. That's 88 degrees. 88 degrees. The supplement of 88 degrees would be 92 degrees. The complement of 36 degrees is what, 54 degrees? Is that right? Okay. 4 plus 2 is 6. 9 plus 5 is 14. That's 146. Well, which of these could be correct? It could be 34, it could be 64. I think 34 degrees is the right number. A regular polygon has 12 sides. What's the measure of each exterior angle? Well, the exterior angle sum is 360 degrees. I divide by 12. That's just going to be 30. What is the measure of angle WZX? WZX, that's this guy right here. Well, that's 132 degrees. And what we're going to do is use this vertical angle and the exterior angle theorem. So 132 take away 52. 2 minus 2 is 0. 113 take away 5 is 8. So 80, so A. What is the measure of an exterior angle of a regular hexagon? Regular hexagon? Well, we can do the exact same. This is the exact same problem as number 56. Instead of 12, they use n equals 6. Okay, 360 divided by 6 is... what is that, 60 degrees? Cool, we got it, 60 degrees. All right, we can keep going. We've only got about a minute left on my recording. For a proof problem like this is a data problem. Sorry, not a proof problem. They do mention proofs here. A data problem has a picture, it has a question, it has the answer candidates, and it has something you can almost always, like 99% of the time, you can ignore the introduction. Oops, there. 99% of the time you can ignore the introduction. So, I jump straight to here. Which statement would not be used in the proof of a Pythagorean theorem? Oh, I know what this looks like. That's B, that's A, that's B, that's A, that's B, that's A. The area of the triangle equals 1/2 AB. I'm going to use that. That's true. The 4 right triangles are congruent. That's true also. I'm probably going to use that. The area of the inner square is equal to half the area of the larger square. I have no way of knowing that yet. So we'll compare this to D. The area of the larger square is equal to the sum of the smaller square and the 1, 2, 3, 4 congruent triangles. That's true too, so it has to be C. We'll probably use anything in here that's true. The new pipeline, you're going to take old pipeline length, old, take away the 2 new side lengths. Onward we go for constructions. Remember, anytime there's 2 arcs, you're going to be putting a line across them. Anytime there's 2 arcs crossing, you're going to put a line across them. This one already has a line, so I'm not going this way. I'm going to go this way. Ah, line through P parallel to line L. Great, thanks.